The statute mile nautical mile conundrum. Oh no, they're tricking us with the facts again. Okay, here's the deal. The Roman mile was 1,000 5-foot paces, and a pace is 2 steps. So 2,000 30-inch steps. That's about 5,000 feet. Under the rule of Queen Elizabeth I, through an act of Parliament in 1592, they declared the statute mile should be 5,280 feet. And it breaks down this way. 1 mile is 8 furlongs. That is 8 furrows long. A furrow being the distance a team of oxen can pull a heavy plow before the animals need to take a break. A furlong is defined as 40 rods. A rod is 5.5 yards, or 16.5 feet. So 16.5 times 40 times 8 is 5,280. That's where our English mile comes from, and it's strictly a legal definition of what a mile actually is. A nautical mile is different. A nautical mile is approximately equal to the surface distance subtended by 1 minute of arc, and it's based on the circumference of the Earth being about 40 million meters. Now, there are 21,600 arc minutes in a full circle. So 40 million divided by 21,600 is 1851.85 meters. Eventually, the nautical mile became agreed to be 1,852 meters. Exactly, or 6,076 feet. Now, what's the length of an arc second? Well, since there are 60 of those in an arc minute, 1,852 divided by 60 would be 30.866 meters. That's 101.27 feet if you do the conversion. And it would apply to an Earth with a radius of 3,956 miles. That, by the way, is about equal to the average of the polar radius of 3,950 miles and the equatorial radius of about 3,963 miles. If we use Earth's equatorial radius of 3,963, you'll end up with an arc second being 101.45 feet, so just slightly different. Now, the contention on the part of some of the flat earthers is that we've just made up these numbers. So I'll share with you a little bit of a math shell game that's being played by a guy by the name of J-Row. And here are his calculations. Let's see if we can make some sense out of it. He doesn't like using units, but I'm going to put the units in there. So he sent me this where he says R, presumably that would be the radius of the Earth, is equal to 21,600. What is that? Well, 21,600 is the number of arc minutes in a circle divided by 2 pi. If we divide the number of arc minutes in a circle by the number of radians in a circle, that's 2 pi, you get 3,437.746 arc minutes per radian. That would be true for any circle. But remember, we have defined a nautical mile to be equal to the distance on the surface of the Earth subtended by 1 arc minute. Next, he provides a variable he calls K, which he says is 3,600 times 180 divided by pi. I can only assume he's talking about 3,600 arc seconds per degree, which would make sense. 60 times 60 times 180 divided by pi, and you end up with 206,264.8062 arc seconds per radian. Now, he has a variable he calls X, where he divides K, the number of arc seconds per radian, by R, the number of arc minutes per radian, and ends up proving that 1 arc minute contains 60 arc seconds. Brilliant. And now things start to fall apart. He now defines another variable he calls small x, and he says that's big X, which would have been 60 divided by 60. Well, that's 1. And in the very next line, he says x is equal to 101.45. Apparently, some magic just happened. That number just came out of thin air. Now, obviously, that arc length in feet has got to be tied to the circumference of the Earth in feet. So now he takes 101.45 times 60, that would be arc seconds, times 60, to get 1 arc minute, which is 6,087 feet. Absolutely. That's exactly what it would be. And then he divides 6,087 feet by 5,280 feet. In other words, the length of a nautical mile divided by the length of a statute mile to get a factor of 1.15 whatever. Then he takes the number of arc minutes and a radius in other words, times that factor, which is the ratio of the feet in a nautical mile to the feet in a statute mile, and ends up with 3,963 statute miles. Absolutely. But here's the problem. We intentionally defined the length of a nautical mile to be equal to the surface distance subtended by 1 arc minute. We intentionally defined the length of a statute mile to be 5,280 feet. We intentionally defined the length of a nautical mile to be 40 million divided by 21,600 arc minutes in a complete circle. But that distance, 1,852 meters, is measurable. We can observe the pole star Polaris, for instance, and we know that if we measure the distance as we move toward or away from Polaris, every time we move 111.12 kilometers, that's 1,852 meters times 60. We'll see the altitude angle of Polaris change by 1 degree. So, quite obviously, the length of a nautical mile is based on the length of a meter. And the length of a meter is based on the circumference of the Earth. Or at least it was originally. Now, J-Row and Mike Jones, his buddy, seem to have a difficult time understanding this. And I thought maybe if I could drop in the On the Level Discord server, we could sort through this. So what's about to follow is an hour and some odd minutes worth of those two guys running from this question. They cannot, nor will they, tell me how 101.45 feet, representing 1 second of arc, comes about if it's not based on the radius of the Earth. Listen and enjoy.
Where's Blue?
Afternoon, fellas.
Is that you, Blue?
Yeah, it is.
No way. That's somebody else taking the piss.
You want me to turn my camera on or something?
No, it's just somebody's doing a really good job, right? We've got some good people doing voices here, Blue.
Well, you know, as they say, mockery is the highest form of compliment. So go right ahead.
Yeah, that's you. That is you, Blue. Nobody else has that little whistle. Oh, welcome. What are you? Have you come? I bet you've come for J-Row, right?
J-Row and Mike invited me in here, so.
And Mike as well, yeah. Well,
Surigaki too, yeah.
Surigaki?
Welcome. I think he might have been the one calling me a coward. Let's see. somewhere back up there. Anyway, it doesn't matter. Oh, yeah. Call me a chicken. Yeah. Without saying it, he just put a chicken emoji on it.
What was it? What's it over? What's the thing? I've noticed you've been going backwards and forwards with J-Ro. We don't really take that much notice. What's it all about? Something to do with an angle?
No. The distance.
What, an angle's a distance?
No, not angles. It's about a
that's
distance.
what Flatsoid and Thingy are doing.
Well, I'm not Flatsoid. I don't care what he does. We've been trying to discover.
Rufus did it as well. It's the opposite side angle, like that distance.
Yeah, gotcha.
That's not what you're talking about, though, no, right?
No. Talking about the actual physical length of an arc second.
Physical length of an arc second?
On the surface of the Earth, yes.
Oh. Well, no, that still doesn't really make any sense to me. But, I mean, you've been talking to other people about it.
Well, it's not too hard to understand, really. We know a nautical mile is 1 arc minute. 1 minute of arc, that's a nautical mile. An arc second would be 1/60th of a nautical mile, right?
Well, I don't know. I never understood that. I know that they've measured the 69 miles, and then they noticed that there was a 1 degree difference, right? But then when they went to the water, they just went, well, we'll call it 1 arc minute is a mile.
Well, it's still an arc minute, whether you're doing it on the land or you're doing it on the water. It doesn't matter.
No, because it would be 69 miles.
That's statute miles.
Yeah.
Statute miles.
Yeah, but all they've done is
miles.
just added the thing.
On the land, a nautical mile is exactly the same as a nautical mile on the water. Yeah. It's all the same thing. And 60 nautical miles, whether you're on land or on the water, is 69 statute miles. 69 point something. The two numbers are exactly the same.
Yeah, well, that's because on the land you can actually measure the 60. You can't do that on the water, right? So they just said we'll call an angle a distance, but I mean, can't really do that in reality, can you?
Well, you can really do that on the land too, Beth.
69 miles.
Or 60 nautical miles.
69 miles actual
sure.
is 60 nautical.
Absolutely.
Providing you're traveling either towards or away from a particular light in the sky.
No, in any direction.
Isn't it just, it's an angle to one particular light in the sky?
No.
Isn't it?
No, it's not.
What?
No, it is not. But hey, I didn't come here to get into all of that.
Yeah,
I want to talk to Mike, who seems to have disappeared. J-Ro's sitting here. Speak to me, J-Ro. Where does 101.45 feet come from? I've shown it to you. You tell me your idea. How do you like that? Challenge me to come into the Discord, and one of them vanishes and the other one won't come off mute. Go figure.
Don't even know if he's around. I know he's in here.
He's been responding with repeated memes in the chat. So
he's been responding with memes?
Yeah.
Well. Oh, he's gone. He's not here anymore, Blue. He's gone. Oh, no.
Yeah, Mike's gone and J-Ro's gone.
Yeah.
How about that? And they invite me
I'm
for
here.
a discussion, and
I'm here. I had my volume down.
Oh. There you go. Blue, he is here.
He goes by arc second now.
He is the arc second. He's moved up the list. He didn't go anywhere, Blue.
who is arc second?
That's J-Ro.
Oh, okay. All right, I'm here. You gonna tell me where 101.45 feet comes from?
Is that a measurement?
It's the length of an arc second.
That's the length of an arc second.
Yep.
That's like an angle.
I said the length subtend. All right. Let me be very pedantic for you here, Bev.
Please, Blue.
An arc second subtends a distance of 101.45 feet at the equator of the Earth.
What, an angle is a distance?
Bev,
I'm still finding this hard. Flatsoid was saying this the other day. You don't think that horizontal is a degree, do you?
Bev, an angle can subtend a distance on the surface of a sphere or on the circumference of a circle. Do you disagree with that?
I don't think. I think the angle's like it in the middle. It's the portion with the two straight lines.
Yeah, and those two straight lines.
Doesn't have a length.
And those two straight lines cut the perimeter of the circle or the surface of the sphere. Do they not? And then if you measure the distance between those 2 points, that is the distance subtended by the angle. That's what we mean.
We have this saying here, Blue. You can do fuck all with an angle, and that means that like there's no length that can be associated with the angle.
All right, I guess this is over with then.
Well, that's just what I know. I mean, you may have been having a different conversation. You must have been having a different conversation. It sounds like you've been talking to Flatsoid.
No, but I don't think I've ever talked to Flatsoid.
Well, that's what they've been saying recently.
Well, I can't help what somebody else says, Bill.
Well, you seem to be backing them up, and I'm not with you. I don't
backing
get it.
Anybody up. This has been an argument that's gone back and forth between me and J-Ro now for the past 3 or 4 days over what
But you're saying that there's some sort of distance related with an angle.
Yes, of course there is. An angle can an angle can subtend a distance on the circumference of a circle. What is a radian, Bev?
What is a radian?
That's an angle.
It's like the radius.
It is the angle that the radius uses up on the circumference of the circle.
Yeah, but you have to know the radius, don't you?
It's always if you want to be in something other than degrees, yeah. Two pi radians equals 360 degrees. So a single radian is 360 divided by 2 pi. That's 57 point something degrees. Easy, right?
Well,
So we
you know,
we can simply say that a radian, an angle, the angle radian, subtends a distance, an arc of 57 degrees. And now, if we know the actual radius of the circle, we can figure out what that actual distance is. Simple geometry. You ain't saying much, J-Ro. Come on.
What do you want me to say?
I want to hear what you think. Where am I wrong?
On principle, you're not.
Okay.
I just wanted to see if you could figure out where 101.45 comes from.
Yeah, I showed it to you.
No, mathematically.
I did. I gave it to you.
No.
That particular version of it, and bear in mind that you can get a number of different measurements that are within a few hundredths of a foot, and it all depends, obviously, on which Earth radius you choose. But the Earth generally is accepted to have a minimum radius, a polar radius of 3,950 miles, and an equatorial radius of 3,963 miles. Now take 3,963, multiply that by 5,280, divide that by 360 and then by 3,600, you'll come up with 101.45. That's where it comes from.
That's not where it comes from.
Well, then you tell me where it comes from.
It comes from the knot.
Oh, I get it. They find an old publication like this and they think because they can see the number like 51 feet representing half an arc second or 50 feet representing half an arc second, that must mean that the arc second length came from the knot. That's the distance between knots in a log line. Of course, they ignore the fact that they start by saying that 1 degree of a great circle is 367,200 English feet. And they don't read the rest of the article that says at one time it was thought that 1 degree was 60 miles, each being about 5,000 English feet, so that's 42 feet between the knots. And they also don't go forward and look at things like, well, for instance, the Cavendish publication from 1798, where Henry Cavendish shows the best known diameter of the Earth at that time to be 41,800,000 feet. That's 3,958.33 miles. Not a whole lot of feet different than the number that we use today as the average. Okay. The knot, which is a nautical mile per hour. Where do you think that came from?
Yeah, the radius you just quoted, 3959, whatever. That's after the fact.
After what fact?
You're working the problem in reverse. You're starting with an end result and working it backwards versus where it really originated and came from and why.
I'm all ears. Go ahead and tell me.
I know. I'm wanting you to figure it out.
Now, that is a bullshit game to try to play, J-Ro. Come on.
It's not a game.
It is a game. You guys are just playing games. Look, you got called out and you can't put up anything. Just admit
Look,
it
you
and be
want me?
done with
You want
this.
me to hand it over to you on a silver platter? I'm not going to do it.
No, you
I
don't
have the
have
fucking
it.
answer.
You don't have it. You don't have an answer, J-Ro.
I do have
You
the answer.
absolutely do not have one. I
You're
have shown
such
you
a
the
lame
calculation.
researcher. You're so lazy and incurious, Blue.
I
Completely
have
lazy.
shown you where it
You want
comes
other
from.
people to do your work for you. You lazy old man.
Mike, drop the insults, please.
You just called yourself old like an hour ago. Well, you know how old I am, Jake? I've been doing this since before you were born. It's a fucking compliment, Blue.
Well, I figured since I know what it is and where it came from and worked it out myself, that Blue, since you like math, you'd do it also, but you didn't.
I did. I certainly did, and I told you how.
Yeah, but you need to prove all of your variables, Blue.
I did.
You didn't, Blue. You got one variable in there that you can't a constant that you can't prove.
What?
What?
It's the 3959. The end result that you started with.
We can prove that. We can measure that. That's something you can actually measure.
Was that given to you or us as a value?
Measure.
That's been around for hundreds and hundreds of years.
Yeah,
yes,
but where did it come from?
Yes, you can measure one arc minute. Yes.
No, but 1 arc minute isn't 3959, Blue. It's just 1 arc minute. 1/60th of a degree.
Yes, I know.
It's oh my God, 1 arc minute is a fucking angle, you dipshit.
You guys are pathetic.
Well, 1 arc minute is it's a distance. 1 arc minute of distance.
Don't have you have shit, Mike. You and
is
J-Ro,
1 arc minute is 1 arc minute an angle or is it a distance?
Nothing.
Is 1 arc minute a distance or an angle?
You cannot come up with 101.45 with any of your hocus pocus bullshit. You absolutely cannot.
Hocus pocus.
For the record, one more time, where do you think they got that value from, the 101.45?
I don't even know that that's a published value, if you want to know the truth, J-Ro. I think I'm the one that came up with that, just calculating what the length of an arc second was.
So, well, like if it's 101.33 or 101.58, whatever, mean value, let's say 101.45. Where did that come from?
Where does that come from? It is 1 arc second of the circumference of the Earth.
No, it's of any circle, right?
No, it is not any circle. It is not any circle.
So any circle doesn't have 21,600.
Yes, every
divisions,
circle has
right?
that. Yes,
And
every circle has that.
And every circle is broken down into degrees, minutes, seconds, right?
Yep.
360 degrees, 60 seconds per minute, or per degree per minute, and then for arc second, that's 3,600 arc seconds per degree, right?
1,296,000 arc seconds in a circle.
Agreed. So where does the 101.45 come from?
Well, let's take 3963 times 2.
Why that? Why do you start with the end result?
That's not the end result.
How'd you get 3963? Where's it come from?
It comes from measurements of the circumference of the Earth. Yep, that's the one they use. That's the one.
I'll be right back.
That's the one you have to use. use 3963 and you come up with exactly 101.4455 feet in an arc second. It is not
Where'd
for
you
any
get
circle.
that from, Blue? Where'd
It
you
is-
get that from?
It is not from any circle. It is from one particular circle that has a radius of 3,963 miles.
Where did you get it from?
It's been measured a billion zillion times, Bill.
With what?
I measured it for one, just with nothing but a stick.
The radius.
Huh?
You measured the radius.
I measured the circumference,
circle.
Bev. You know, there's a handy thing called pi. If you know what the circumference is, you can use that pi thing and find out
So
what
you
the
know the
radius is.
circumference.
Yeah, you can measure it. Anybody
How'd you
can.
measure the circumference?
I did the Eratosthenes method along with Bob the Science Guy. We both did it at the same time, about 10 degrees of latitude apart.
Is that
And
when he went travelling?
No,
Was he weighing stuff? That was when he did his trip, weighing shit, wasn't it?
no, that's not when we did Eratosthenes, Bill. We did Eratosthenes years before that.
Is that your introduction into it? Is that your first video?
My very first video, yep.
Is that when you did it with Bob?
Yeah. Yep.
When you measured an angle?
And measuring it, well, sort of, yeah. You can use angles if you want to. I show in the video ways where you don't need to use anything other than a compass.
Drawing compass.
Hmm?
A drawing compass.
Yeah. You should
You
watch
just
the
can-
video. It's
You can do
pretty.
it with
It's pretty
just a
interesting.
compass. Compass only.
Yeah.
Radius measurement.
Well, taking your the measured angle from your observation, yeah. You don't need to use trigonometry. You can find it without all that.
Yeah, but like I say, Boo, we say you can do fuck all with an angle.
Well, you might be fucking wrong too, Beth.
Well, you're just using an angle.
You might
aren't
be
you?
wrong.
And coming up with a distance.
You might be wrong, Beth.
Well, yeah, you'd have to show us how you managed to do this.
Well, all you got to do is watch the fucking video.
Got Nathan Oakley.
All you got to do is watch the video.
Helping Nathan Oakley.
I'll be glad to show it to you if you want to.
How you develop an angle to a distance.
I can show you. You can watch the video yourself, or I can play it right now if you like. It's really, really simple. It uses logic, so you might have a little hard time following it, but
No way. It uses logic. Geometry.
geometry, a little logic, yeah. Mm-hmm.
Measured angle. Yeah, that sounds great. Any other assumptions or something?
Nope. Only that you know how far away from the subsolar point that you are. That's all. That shouldn't be an assumption.
Well, that's not. Yeah, that's a distance, isn't it?
You have
That's
to know
something
that.
else other than the angle.
Yeah, you have to know that. You have to know how far away you are from the subsolar point.
What's the subsolar point?
You don't know what a subsolar point is? The point on Earth where the sun is directly above you at your zenith. Now, there's one handy time of the year that you can do this where you know where the sun is. It happens twice a year. It's called the equinox.
I'm pretty sure the sun never gets above me.
No, you only have to know how far away you are from the sun when you make your stick and shadow measure.
You can't measure how far away you are from the sun.
Okay, Bill, whatever. I can. I don't know why you can't, but I can.
You can.
Sure.
Oh.
I use Google Earth. I mean, you can complain about that if you want to, but
You use what? It's not a measurement.
to find the distance,
You can't
that's what I
measure
did.
using Google.
Well, sure, Bev. Look, I know you didn't. You can just.
At least when I was doing surveying, Blue, you cannot measure using Google.
This just simply
Things might have
doesn't
changed.
anything.
I mean, it is 2024.
Simply doesn't have anything to do with the conversation. All you're doing is just trying to wiggle out of this. That's all you're doing. So I applaud your effort to run interference for J. Rowe and Mike, but it's not going to work. The only question was, where does 101.45 come from? I contend and have contended that number is strictly based on the equatorial radius of the Earth being 3,963 miles. That's where 101.45 came from. J. Rowe's been trying to claim that's true for any circle. No, hell no, it isn't. You have got to have an actual length of the equator.
Length of an equator?
You have to know the equatorial circumference, yes.
The sphere.
Yep.
And you say you've measured it?
Yep. I got within 25 miles doing it my way.
You and Bob?
Yep. Yeah, the reason for me and Bob doing it is because we're at two different latitudes. And although my numbers were closer than his because he only used a really short stick thing. I used a 6-foot painting pole basically for mine. So I got a lot better.
6-foot painting pole?
Well, I got a better accuracy. Call it a stick, a 6-foot long stick, Bev. That's what I used, okay? So I had a longer shadow.
Did you get an angle on the end of it? Or?
So I got a longer shadow, so it's easier to measure the length of the shadow. You get a more accurate measurement of the length of the shadow because my stick was longer than the one Bob used. But forget about that. He still got fairly close.
So it was a measurement of the shadow length.
Here's the problem, though. If you take the angles the altitude angle I had measured, in other words, the shadow length, if you take my angle and known distance to the equator, you can easily, with trigonometry, figure out how high the sun would be if this thing were flat. It's not. Because when you use Bob's numbers, his sun would have to be at a totally different altitude. That's the reason doing them at more than one
definitely not flat.
But sense.
So why would you be trying to work out how high the sun would be?
Just to show that it's not flat. Just to show that the Earth is not flat. To show that the Earth that this fits with an Earth that has that is a spherical object. That's why.
Everybody knows it's not flat, right? So
that's a
what does that even mean?
You were working out how high the sun would be if it were flat. That sounds like
that's the silliest
flat
argument anybody ever made. That's just crazy.
Well, yeah, I know.
Flat the ground is not flat.
How crazy it is.
Of course,
flat earthers don't even do it.
I know you're trying to get away from this other issue, but let's sort that out. Tell me again, J-Ro, where did 101.45 come from, and how do you think that would apply to any circle?
I'm simply asking you to work the problem the other way around. Start with the beginning instead of the conclusion. That's it.
What do you see the beginning being? I have no idea what you mean when you say start with the beginning. What does that mean?
Where the knot came from.
Don't think he's talking about the not that either. I think he's talking about like the not.
Right. And within that, it could be the not that. The knot that's not that knot. I know that doesn't make sense to you guys. But
And somehow or the other, if I do this, I'm going to find 101.45. I have no idea how long, how many thousands of years sailors may have used ropes with knots tied on them as a way to measure their speed. I don't know. That's the extent of my knowledge of it. Back in the ancient times, that's what they would do. They'd take a piece of wood that would float. They would tie a rope to it. They would tie knots periodically in the rope, and they would simply count how many knots went over the stern in a given amount of time to give them a speed.
that's right.
Speed relative to the water, though, right?
Yeah.
Yeah.
That's how they figured out what their speed was.
Relative to the water.
I don't know if they just, I don't know. I don't know how far apart the knots were or anything. I suspect that there wasn't a lot of standardization to it.
Oh, but there was. Over time, of course.
Became a lot of standardization once people said, okay, what we're going to do is define a nautical mile as 1 minute of arc.
Yeah. To fit a model. Exactly.
Well, the model seems to work because you can measure 60 nautical miles on land, and you can look at Polaris and you can see your latitude change by 1 degree.
You can pretend that you can call 60 nautical miles 69 miles, but the only really measured one would be the 69 miles.
Bev, that is so stupid to even say.
That's an actual
It's really
distance.
not.
It is totally stupid to say.
It's really not.
You're telling me that you can measure 5,280 feet, but you can't measure 6,000, whatever that number is, 76 feet.
Wait, what'd you say? You broke up. On my end, at least.
I said, you're trying to tell me that somehow or the other you're capable of measuring 5,280 feet. That's 1 mile. But you can't measure 6,076 feet. That's 1 nautical mile. Is that what you're telling me?
You can, but that would be the wrong proportion over water.
No, it wouldn't. It's exactly the same. Identically the same.
What is a statute mile to a nautical mile?
That ratio doesn't change no matter what you're over.
Well, the actual mile, Blue, that's a distance. Straight line. isn't it? A mile, 69 miles. It's a straight line.
What's your point?
Weren't you talking about an arc distance? Because an arc distance isn't a straight line. So they can't be the same.
I'm talking about 1 mile. Actually, I'm talking about 1 foot. Gets right down to it. But let's do it for 1 mile. How different do you think the arc length over 1 mile versus a straight line connecting the two endpoints of that arc? How much difference?
The point is that they are different.
How much difference do you think there is?
They're just different. As different as a straight line is from a not straight line.
Okay, well,
That's the difference.
We'll accept the error because it's almost nothing.
You're really saying the difference between a straight line and a curve is almost nothing, so we can get rid of it. Then there isn't any difference.
A curve with that radius over that distance, the difference is almost nothing, yes.
Is there a difference?
Oh, yeah, there has to be, obviously. But
so there is a difference.
So what?
Between a straight line and a curve.
So what? It's a surface distance. That's what we're measuring. Whether it's straight or curved, it doesn't matter. It's the surface distance. So do we agree that if we can measure 5,280 feet, we could also measure 6,076 feet? And that it wouldn't matter whether you're over sand or dirt.
Do we agree that there's both straight lines,
water.
distances, Blue?
I'm not worried about straight lines. I'm just saying across.
5,800 and whatever feet is a straight line, and the 6,000 and whatever, that's also a straight line.
Okay, fine.
Just one of them's longer than the other.
There you go.
There's a difference of whatever the portion is.
About 15% different.
15%. In length.
Yeah.
Right?
Yeah, 6,000.
So there's no difference in straightness.
Newsflash,
But there is a difference
6,076
in
feet
length.
is 15% more than 5,280 feet is. Yeah, they're two different lengths. They're two different lengths because they came about two different ways.
One of them, you just said, well, let's say if 69 miles is 1 degree, because we're on the water and we can't tell, can we just say that 1 arc minute is a mile? It's near enough. I think that something like that.
That's essentially what you do.
Well, not really. Because nobody else equates an angle to a distance, as far as I know, anyway.
Well, except everybody that's ever done celestial navigation.
Have you ever done celestial navigation, Blue?
I haven't done it in a long time. I got rid of my sextant when I got rid of my airplane. I used to carry one in the luggage compartment of my airplane.
Yeah, I've actually got a sextant here still. I haven't got rid of it. But I mean, celestial navigation? I've never done that. Have you ever done celestial navigation, Blue?
Yeah. Been a long time.
Do you want to give Nathan a hand? Have you ever... Do you want to go over there and have a word with him about this?
No.
No. You can both have a laugh. Because Nathan Oakley's going around saying that I'm stupid for saying you can do fuck all with an angle. But you can change it to a distance. You should tell Nathan.
Well, if you can't understand that an angle subtends a specific distance on the circumference of a circle, I don't know what to say.
You are measuring the angle externally, aren't you?
I'm pretty sure if I sit down at the center of a circle, it has a circumference of 360 inches. And I draw out a 1 degree angle, 2 lines beginning at the center, 2 lines separated by, and that's what an angle is. It's that area between 2 lines. 2 lines separated by 1 degree. If the circumference is 360 degrees, or is 360 inches, then 1 degree is 1 inch. I'm real sure of that. Now, statute miles came about as the
Nathan Oakley said, you said at the center of the circle, and Nathan Oakley was saying the other day that the radius of a circle. I think Nathan Oakley said that's the flat plane. You getting the? Is that right?
Well, Nathan Oakley has no idea what he's talking about, so I don't listen to the guy.
Well, he did say that. I think he said that some people got the radius from a flat plane measurement. His radius, he said, from the flat plane that he talks about. Well, we call it pleonasm, right? Yeah. Ridiculous.
If anybody says more shit that's wrong than you, it's him.
But if you're measuring the angle at the center, then you're at that little bit where you do measure angles, right? A portion of a circle. And the circle that you're talking about, right? It's the same circle that Nathan Oakley's talking about, isn't it?
No, I don't think so. I doubt it is. I don't. Circle. To be honest, Bev, I don't know. I don't listen to Nathan.
Well, I like listening to the stupid shit people say. There's loads of people saying some really stupid shit. But like Nathan's going around saying that, you know, geometrically, he can do something with just an angle. Same as you.
Now let's go back and talk about miles. Where do you think the statute mile came from? You ought to know, Bev. It's your country that did it.
I heard the original one was the Roman centurion. It's like steps.
Yeah, they had all kinds of different opinions, and that was a source of confusion, especially when people were calculating how much land there is involved and that sort of thing. And they needed, I think that's part of the story. They needed a more defined distance that they could say this is a mile. And it was the British Parliament that enacted that. I forget the dates now. It's back in the 1600s, I think. And they already had the length of a foot and the length of a rod and the length of a furlong. And if you get the right numbers of all those things, you end up with 5,280 feet. And what happens at that point, it becomes a statute mile, in other words, a legal mile by statute. Right. So that's where the statute mile originates. The nautical mile is a little different. To make life easy for navigators, they decided to say, okay, a minute of arc should be a nautical mile. That's easy enough, but that needs to translate into a distance. So what units of distance would you use? Well, there have been things. There's been a thing called a meter that's been around since the Roman days, I think, but it didn't have a real, wasn't really tied to anything. There was another unit that was used around Europe. I know the French used it. I think the British used it too. And I'll probably mispronounce it. It's called a toise. It was roughly 2 meters, more or less. But the French Academy said, okay, here's what we're going to do. We want the meter to be equal to 1/10,000,000th of the distance from the North Pole to the equator. And that's how the meter was being defined at that time. Now we've got a different way of tying it to things today.
So why do you think that they chose 10 million?
Round number.
It's a bit of a weird round number, isn't it?
Yeah, it was just a round number.
So they arbitrarily sort of said, let's call that 10 million, and then we'll know what a meter is.
Yeah, that'll make
when we backtrack it.
That'll make the circumference 40 million meters, right? 10 million is a quadrant, so.
If you assume a circle, right?
Yeah. Well,
yeah, that's the circle that Nathan Oakley's talking about.
Well, that's a sphere that I'm talking about, but whatever.
Circle, 540 degree triangle, right?
So now that we say we have a length that we say is a meter, and it's 1/10,000,000th of the distance from the equator to the North Pole. We've also defined a nautical mile as 1 minute of arc. Well, how many minutes are there in that? 10 million meters is 90 degrees of arc. So 90 times 60 is 5,400.
Wait a minute, Blue.
What?
A meter's a straight distance, isn't it?
Well, you can take a string that's a meter long and wrap it around a pole if you want to, Biff.
Yeah, I know, but I mean, if you put a load of meters together, if you put 10 million meters together, I mean,
okay,
it doesn't curve, does it?
I know you're going to try to
doesn't know, does
obfuscate your way around this, but let's just finish finish what we started. 10 million meters from the North Pole to the equator is what we've got to begin with, but then we've got a nautical mile that is 5,400 arc minutes. 10 million divided by 5,400 is 1,851.85 meters. Over time,
what would you say to the people that know that a meter's a straight line? What would you say to them?
It is a straight line distance, Biff. Doesn't mean you can't measure the length over a curve with it. Do you not have a flexible tape measure of any sort? Of course. It'd be just silly to think that you can't measure a curve. How would you ever get the circumference of a circle if you can't measure it?
Measure it with a straight line.
So anyway, eventually everybody came to their senses and said, okay, look, we can have all these little funny fractions, but it's almost 1,852 meters. Let's just call it that. That will be the length that we will call 1 nautical mile, 1,852 meters.
They finally settled for near enough.
Yeah,
that doesn't sound like a mathematical thing. That's what we've been saying to Nathan Oakley. right? You can, with one angle, you can do absolutely fuck all with it because you've just got an angle. You need some other things, but then you'd have to be dealing with the, the realms of mathematics, and that's pretty precise, Blue. Not roundabout. Let's everybody agree that it's near enough. That's not how mathematics works.
Well, anyway, that's why a nautical mile is the length it is. That's why a statute mile is the length it is. And that is why 1 arc second subtends 101.45 feet using the equatorial circumference. Now, absent any counterpoint on the part of Mike or J-Ro, I'll call it a day.
Thank you very much, Blue.
And so we leave the folks at On the Level with one final thought. Guys, when we say, how stupid can you be? That isn't a challenge. That's a question. Hey, thanks for watching. Hope you guys enjoyed it. Don't forget to like and subscribe, and we'll see you guys on the next one.